Hello and welcome to your next online statistics class. And last week we looked at measures of location, which is basically different forms of averages, different forms of means. This week we'll have a quick look at measures of dispersion. Basically, these are the measures that show how spread out the data is. Dispersion is sometimes important, as in the next example. Let's say you have a choice of crossing one of the following two rivers. Both of them have an average depth of only 1 meter, but the depth of the first river ranges from as shallow as 40 centimeters to as deep as 1.6 meters. That's a little bit too deep for crossing. Whereas the depth of the second river ranges from 80 centimeters to 1.2 meters. In the case of the second river, the range is much closer to the average, meaning that dispersion is smaller. So small dispersion indicates that data are located closer to the mean, whereas a large dispersion shows that data are more spread out away from the mean, in which case the mean, of course, is less reliable. Now let's have a quick look at how do we calculate measures of dispersion. Here we'll have a look at variance and standard deviation. Let's say we have 30 students over here, and these are their student IDs. And say we have these grades. One quick way to calculate variance as one measure of dispersion is to use Excel formula, which is equals var dot, and here we have a choice, either a variance for the population or a variance for a sample. This, of course, is not the whole population of all of the students in this country. Instead, it's just a sample of 30 students and their grades, so we need to choose the formula for the sample variance. Double-click that, enter all the grades in the formula, hit enter, and we have our answer. Variance is 206.7. There is actually another way to calculate variance, much more involved, but it might be useful when working with grouped data. So let's have a look at that involved way as well. First, for that, we'll have to calculate the mean. We've got our mean. Next, we'll have to calculate the difference of each of the observation values of each of the grades from the mean. To keep the heading within one column, I'll just call it diff. F4 to fix that reference to the red cell and copy the formula. I want to look at all of these differences together, but some of them are positive, some are negative. I don't want them to cancel each other out, so I'm going to take the power of 2. So I'll call it squared differences. Difference into the power of 2. Next, I want to add up all those squared differences and finally divide them by 29, as that's the number of observations minus 1. That is the formula. D75, a reference to the blue cell, is the total sum of all the squared differences, and 29 is 1 less the number of observations. As we see, the values are the same. However, there's also another measure for dispersion, because within the process of calculating variance, we took the power of 2 of these differences. So the units of measurement for the variance would be something like a grade squared, something strange like that. So another measure for dispersion is standard deviation, which is a square root of variance, which would have the same units of measurement as the observation values themselves. Square root of grade squared is just a grade. So standard deviation is the square root of variance. There is also an inbuilt Excel formula for standard deviation. That's stdev dot, and we need to choose the sample standard deviation again in this case. Enter all of the grades, and we have our standard deviation. I hope you learned something about measures of dispersion from this short video. I wish you a nice day and go have fun.